guys, so we come up with the last topic for this chapter. Last topic means the third part for this chapter, work, energy and power. That is called the power. So we haven't given any introduction about the power. So here I'll going to introduce what exactly is the power. So power is in everyday language we associate power with the speed. For example, in karate, we say that the powerful punch is that which is delivered at a great speed. So now let's study what exactly is the power. Now guys, power. Let's look what is the power. So we define power by the thing that power is the work done per unit time. That is, if we take the delta W, a work done in time, small time delta T, so the average power we can define by P average is equals to delta W by delta T. So this is the formula, but the average power becomes instantaneous power as delta T approaches to 0. Therefore, applying the limit delta T approaches to 0 for the average power, this becomes instantaneous power and we define it as by dW by dt. Now, as we have done that, that for a particular force, smaller work done is equals to F dot delta S. So therefore, if we say that the power, instantaneous power, by taking the limit delta T tending to 0, this will comes out to be F dot delta S by delta T. So this will comes out to be F dot ds by dt, and we know that ds by dt is equals to velocity, v vector. That is ds vector by dt is equals to v vector. So therefore we have replaced it with the v vector, and we said that this is the formula for the power. And the one example is there, the centripetal force is always act perpendicular to the velocity, so power due to it will be 0 because velocity will be along the tangent. So therefore force or the centripetal force and the velocity will always going to make an angle 90 degree, hence power will comes out to be 0. Now let's look at the example. So this is the example, what is the average power necessary to move a 35 kg block up a frictionless incline 30 degree incline at 5 meter per second. That means what is given to us, that this is 30 degree, this is theta equal to 30 degree, and the average power to move a block, let's say if we make the free body diagram of a block, mg will going to act in the downward direction, something like this, and the normal will going to act in this direction. So if we'll take the component of this mg, so it will be mg cos theta and mg sin theta. That means for the power, force will be mg sin theta, because this much will be the force required to move, or this much will be the force required to work against the gravity. So therefore what we are going to get, power, as we know that the power average is equals to work done per unit time. So what we can write this as, at 5 meter per second and 30 degree incline, or else we can write according to the thing that F vector dot V vector. So therefore what we can write this as, V is equals to 5 meter per second, this is given to us, V equals to 5 meter per second. So this power will comes out to be mg sin theta into V. Now V and this sin theta are making an angle 0 degree, so this will comes out to be mg sin theta into V. or else m, where theta is equals to 30 degree, so power will comes out to be m g v divided by 2. That means mass is given to as 35 kgs into 10, or instead let's take it as into 10 into 5 divided by 2. So this will comes around nearly around 860 watt. So therefore the option should be, correct option should be 860 watt. A stone of mass m is thrown from Earth's surface at an angle alpha to the horizontal with an initial velocity v0. Ignoring the air drag, the power developed by the gravity force in time t seconds, or after the beginning of motion, t seconds after the beginning of motion. So therefore what we have to use, this is the case of projectile. This is actually the case of projectile. So in this question they have mixed the case of projectile, that this is given initial velocity v0 and making an angle alpha, and this will go something like this. So after time, so what we have to find it out, power developed. That means we have to find out the power. Power we can write it as work done per unit time, and we know that work done from the kinetic kinetic energy theorem, or the work energy theorem. We say that the work is equals to change in kinetic energy divided by t. So therefore this will comes out to be 1 by 2 m v final square minus v initial square divided by time. Therefore if we will be able to find it out, because v initial is given to us as v0, v initial is given to us as v0. If we will be able to calculate v final, then the question then we'll be able to solve the question, or we'll be able to tell what exactly the power. So therefore let's find it out, what will be the v final after time t. So what we can say, that as there is no acceleration in the x direction, so what we can say that the v final component of x of v final will be equals to v0 cos alpha. But v in along y direction we have to apply the equation of motion, as the g is the constant, or the g is the acceleration due to gravity. So the final velocity along the y direction will going to change. It will not be v sin alpha, so it will v0 sin alpha, so it will be vf along y direction will be equals to initial, that is u plus at. This is the equation I am applying. So it will be v0. Now u will be along y direction, and acceleration will also be along y direction. So it will be v0 sin alpha minus ay, because ay is equals to minus g. So it will be minus gt. So therefore what we can write this as v. So therefore v final will be equals to v final x component square plus v final y component square. So what we are going to get, v0 square cos square alpha plus v0 square sin square alpha plus g square t square minus 2gt v0 sin alpha. This is what we are going to get. Now therefore what we will get this as v0 square, because cos square alpha plus sin square alpha will be 1. So v0, this will comes out to be v0 square plus g square t square minus 2gt v0 sin alpha. So therefore this is the v final we got. Now what we have to find, that v final, this is the v final square we got. This is the v final square. So v final square minus v initial square, this will comes out to be g square t square minus 2gt sin alpha. So therefore this is what we got, and and we have seen that power is equals to m by 2. Power is equals to m by 2 t times this we got, so I'm directly multiplying it over there. So this power will be equals to m by 2 t g square t square minus 2 gt sine alpha, or else we can write this as m g mg. So since I'm taking gt outside, so this will comes out to be gt divided by 2 minus 2 v naught. 2 will also going to get cancelled, so it will be minus v naught sine alpha. Let's check it out the options. So we have the first option as this mg g by 2 gt divided by 2 minus v naught sine alpha. Okay guys, we have seen what exactly, or we have studied the power. Now I hope that you understood this thing. Now this doesn't mean that we came to an end, but exactly we have the next part, or the last part left with us, that is called the previous year JEE questions. So for that part, stay tuned with us.